Strength is irrelevant. Resistance is futile. We wish to improve ourselves.
Hello, welcome to another episode of CleaveTech Tech Tips. If you watched last video, you would see that we were talking controllers, and in particular, a nut. Well, we solved that problem, but we also noticed another problem, and it was to do with this circuit board. So after the intro, we'll take you back, find out what the problem was, and we'll fix it. And one of those issues I have actually spotted here. Clearly it's probably been corrected, but I might just test it. See these two tracks here? This one that runs up there and that one that runs down. There's a very small gap between them. I think somebody's run a knife between them. So maybe the circuit board, as they was joined, it wasn't etched 100% from new, and they've just done a little score across there. So I want to make sure that those are not actually joined, because they shouldn't be joined. Because if they're joined, then it's almost like having one big step on your controller rather than two smaller steps. Now, to test my controller, I'm going to be using my multimeter. But a cheap one will do for most things that you need to test on your controller. Again, I'll put a link in the description of the video where you can get one from Amazon. So I'm going to try my one here on the diode setting and the little speaker bit, or the little sounding bit here. That's the continuity setting. So that setting on the multimeter tells you if there's a connection between the two probes. So if I put them together, you might hear it beep. There we go. So it tells me that there's a connection between those two probes. So I'm expecting there to be some resistance between these two strips on my controller. So let's give it a go and see what I get. See if it beeps or not. So you might have heard there was a beep between these two here. So if I put it on there, see there is a beep, but then there's also a beep between some of the other ones. So I'm assuming that the resistance between those strips on the controller are actually quite low. So in order to check out to see what the lower resistance is between these bands, I've now set my multimeter to the resistance setting. And that will tell me what the resistance is in ohms, because I've set it to the ohm scale, between the various bands on the controller. So let's see what we get. So I'm not going to measure those two at the moment that are close together. I'm going to measure the two previous. So previous to that, I'm getting 47 ohms. And then the two previous ones, 47 ohms, going back again. 47 ohms. So I'm assuming that each band of the controller seems to be going up 47 ohms. What is it the other side? There's 47 there. There's 47 there. So what do I get between these two that are close together? Well, I'm getting 33, 32. So there obviously is some form of connection between the two. There's not as much resistance as there is between all the other bands. So I'm going to run a knife down here just to make sure that there's nothing caught between those two tracks. So I'll just run my knife down between these two tracks here. Well, it's picking up some carbon out of there, I can tell you. Already I can see bits coming out from between those tracks. So I'm just carefully running my knife in between them, like that. Brush that out the way. Run it back, being careful not to push too hard, because I don't want to scratch the track itself. I just want to run up that gap in between the two, just to make sure that they're not joined together. One final pass back down, just to make sure there's nothing there now that I've wiped it off. Clean that out. Now let's try it again. So, set my meter back up, going to measure ohms again. But what I've done this time is I've actually cleaned the tips of my probes up a little bit. Now these are brass tips on here, so they do tarnish. So I've taken a little bit of wet and dry paper again and just polished up the tips my probes to get a better contact on the circuit board. And let's see what we get this time. So I'll check a few of the tracks before, just so I get a baseline figure. See, we're cleaning up my probes. I've now got it down to 35.9 ohms there. Let's go again. 36 ohms there. Let's go across another one. 36 ohms. 36 ohms. And let's do the one that I've just cleaned up here. 36 ohms. 36 ohms. So we're being fairly consistent now with each band of my controller, or this controller here, in that I know that there's no more resistance between these two here that are really close together than some of the others. So I'm quite happy now that I've got equal steps all the way through my controller. Now it's worth mentioning at this point that not everybody's controller will be set up with equal steps throughout the whole band of your controller. Some controllers have different resistances for different stages of the controller. But I know this one's supposed to be the same because I know all the resistors on the back are all the same value, and I'm pretty sure I built it in the first place. So I do know that they're supposed to be the same resistances for each one, hence why I knew what I was checking. But if you don't know what you're checking, perhaps have a look at resistors on the back. If you want to learn how to use a resistor color code, go ahead. It's actually fairly straightforward, but you could measure the resistance as well of the resistor on the back and see if it still worked out to be the right resistance across your board at the key points where you think there might be an issue. But I'm happy with that, and I've just shown you a way to clean up your circuit board and make that wiper move nice and smoothly across the board. So we fixed this little problem. What else might we find when we look at the rest of the controller? Well, you'll have to stay tuned for the next video, coming very soon on CleaveTech Tech Tips. Hit the big C here if you haven't already. Subscribe. Thank you. Bye.